Okay. Hey guys, this is Kushal Agarwal and Kang Yufeng, and we are in Group 11. And we're going to talk about song recommendation and artificial intelligence. So the first thing we're going to talk about is introduction to AI and recommendation system. So AI, what is AI? Artificial intelligence leverages computer and machines to mimic the problem solving and decision making capabilities of a human mind. So first of all, there are many definitions of artificial intelligence, and this one seems to be the most accurate to us. So what we believe is AI is the science of making computers intelligent and intelligent enough to understand and respond to our human intelligence. So let's talk about positive impacts of AI. AI is capable of learning from experience, which helps in terms of accuracy. The more the data pass into the program, the more accurate it is. And we also know that AI can dig and analyze a set of data close to its deepest point. This trait helps us understand and work with data better. So when we talk about data, we're talking about millions of elements. And there are times where there's only so much a human mind can analyze, but a strong algorithm can dig a lot more deeper and give us information that we wouldn't find ourselves, and that can help us manipulate and work with the data better. And AI can also find structure and regularities in data, so the algorithm can acquire skill and work to its potential. So for example, we see social media apps recommend you posts according to the kind of posts you usually interact with. And here what happens is the algorithm learns from your pattern and recommends you accordingly. And this is a very similar way our music recommendation algorithm is going to work also. Let's also talk about the negative impacts of AI. So since we know that AI is able to do a lot of human jobs, a lot of jobs in the software industry are under threat because of this advent. Intelligent systems are capable enough to replace numerous human jobs because, well, they aren't smart enough to understand it. And the dependence on AI has increased dramatically in this past decade. People are relying so heavily on AI to do the job for them. For example, we see smart homes being activated. We can turn off the switch by not even getting off our seat. And we also see automated cars making a huge impact, and we don't even drive without sitting in the car. And lastly, AI has also been a significant player in the stock market, and we see algorithmic high frequency trading very often lately. So what HFT it's when a computer sells a number of stocks. By number, we're talking about millions of stocks at alarming speed to generate minuscule profits. A lot of companies do this to sell and generate profits. And since the market is very interconnected, this can affect the whole market. For example, this kind of HFT trading in an airline business can affect a hotel business and the rest of hospitality business very dangerously. And lastly, what are the importance of song recommendation systems? Why are we doing this? What we believe is that accurate song recommendation systems can reduce significant amount of your time that goes into selecting songs. Like when you're focusing while studying, you want to change the song, but you don't want to select it yourself. So this system can do it for you and save you a lot of time. And song recommendation systems can suggest you songs that you have not previously listened to, but you would most likely like according to your taste. And lastly, our recommendation system can not only be applied to songs, but in many fields. We've seen that it can be applied to social media, and it can also be applied to online shopping and many other things as well. All right, Kang, you take it away.
Okay, so then we'll talk about the code implementation of our project. And first is the data source of our project. The data set is from Kango.com, and it is Spotify top 50 songs in 2021. In this data set, there are multi-columns such as energy, popularity, etc. So in this project, what do we want to do? First, we will pick two features that we think are most important. And in our project, we choose energy and acousticness. Then we will classify the sound depending on the modularity of a track. We were using K-means cluster, which is entropy-based assessment of cluster in unsupervised learning. Then here comes to our step of coding. We can start to classify our data. Since the data set we get is already well organized, we do not need to do much data cleaning. Basically, we need to make a new copy of our data, keep the columns that we need to use. For example, we have the basic information of the song, such as artist name and track name. And then we have two features that we need to analyze for our learning method, which is the energy and acousticness. And finally, the final column is the feature that we want to classify, which is the mode. Then we can plot our graph. As you can see, we have acousticness as our x value and the energy is the y value. Each point in the graph represents a sum. Since we use k-means cluster, we need to find out what is the value of ks. To find k, we can use SSE, which is the sum of squared errors. It can be calculated. Oops. It can be calculated by the sum of squared differences of the distance between each centroid and its group point. After we find the value of SSE, we can determine it by using Abel technique. So the graph of SSE is just like an arm. The reasonable value of k is the position of the apple in the graph. Here is the SSE of our dataset. As you can see, when we just have one cluster, it has the largest SSE. Using Abel technique, we choose 2 as the key value. Finally, we can show the cluster of our data based on the k values. The point of stars is the centroid of each cluster. The points are divided into 2 parts, and each cluster is a kind of mode, minor or major. Therefore, we can make the conclusion of our code. Basically, by classifying the songs, the apps could have the ability to push the new songs that user will prefer. Honestly, we do not get the perfect outcome. As you can see, the mode column is the actual mode type of each song. And the last column, which is the cluster, is the outcome we predicted. Therefore, the cluster cannot distinguish the songs with different modes. We conclude 2 possible reasons for this outcome. First, maybe there is no direct relationship between the mode and energy/acousticness. Or we choose the wrong value of k, since the Abel technique is an approximate method to find k. We will adjust this variable in the future. And this page is our citation for the project. And this is how I did so far. Thanks for watching.